Hello everyone, welcome to my new programming club. Today we will be solving the problems of weekly contest 360. Now let's begin with the first problem of the contest. And the problem's name is furthest point from origin. So you are given a string moves of length n consisting of only characters L, R and underscore. The string represents the movement on a number line starting from origin 0. In the ith move, you can choose one of the following directions. Move left if the moves I is L, or basically, let me explain it in my own words. So you will be given a string according to, let's say, let's take a sample example. Let's take this example. Now each empty space or say underscore can be replaced by either L or R, and L will move you to left direction and R will move you to right direction. It will increment your coordinate on the number line. It will decrement basically. Left will decrement and right will increment your coordinate. So for example, if you are situated at 0 initially and you encountered L, then you will be moving to -1. Then this blank, we can choose any of the lengths that we may like, and any of the direction we may like. We can choose L or R. It's up to us which we will choose. So you have to return the distance from the origin of the furthest point that you can go after n moves. So the thing here is to be noted as is that the distance that you are asked to state that you will be go till will be the maximum distance that you can go, and it can be either in the left direction or right direction. The direction does not matter. So this is the hint for solving this problem. The direction does not matter really. So basically what you will be doing is you will be taking the absolute difference of number of occurrences of left and right, absolute difference, and adding uh, underscore occurrences to it, occurrences of underscore to it. It will give you the length of the maximum distance that you can cover. So because if there are left and right both values present, then to some extent they will cancel each other out, and so it's very intuitive to take absolute of both of their occurrences difference and then add the blank one to the which one is having larger value. If let's say there are five lefts and three rights and two blanks are these underscores. So it is very intuitive to add number of blanks to left. So all of the two remaining blanks will be made left only. So the number of left will be 7 and the number of rights will be 3. So we will subtract them and we will get 4. So similar thing we are doing here also. So 3 and 5 difference is 2, and we will add the blank occurrences and it will be 2 plus 2 is equal to 4. So this is the approach to solve this problem. We are doing nothing but counting the occurrences of left count, right count and blank, taking their absolute value and adding the count occurrences of blank to the absolute difference. So this wraps up the solution for the first problem of the contest. Now let's move towards the second problem of the contest. So the second problem's name is find the minimum possible sum of beautiful array. You are given positive integers n and target. An array nums is beautiful if it meets the following conditions. Nums length is equal to n. Nums consist of pairwise distinct positive integers. So all the integers in the nums array should be distinct. There does not exist two distinct indices. I and j in the range 0 to n minus 1 such that uh, so basically there should not be two numbers in the array uh, whose sum will be equal to target, and you have to state the minimum possible sum you can the array can have. So it is very intuitive to check all the numbers on the number line starting from 1 to make the minimum sum possible, and we will exclude only those numbers which can form uh, sum with another number taken equal to target. So if the current number can form a pair with already taken number with sum equal to target, then we will ignore the current number. Then current number will be ignored, else the current number will be taken. And we will check the bounds of the length of the array that is given to us and the bounds of the target. So we will take a sufficiently large number on the number line till which we will be doing a single iteration over the number line. So I have taken 10 raised to power 9 plus 7. It is a sufficiently large number to accommodate all the cases. So that's what we have done. And to check whether there is a pair such that the current number sum with that previous number taken equals to target, we have used a set in order to check the occurrences of pair, such pair in O of one time. So this is why we have taken the set, and as soon as we hit the number of numbers that we have taken becomes equal to n, we will return the sum, and it will be the minimum sum possible, and this will be our answer. So this wraps up the second problem of the contest. Now let's move on towards the third problem of the contest. So this is the third problem of the contest. Its name is minimum operations from subsequence with target sum. So what is the problem statement? You are given a zero indexed array nums consisting of only non-negative powers of 2. So and an integer target. So what you are having is, let me quickly take another slide. You are given a array nums. All the elements in this array are powers of 2. So if you represent a power of 2 in a binary representation, let's 0, 1, 2, 3, 4, 5, 6. These are the positions. So this is 2 raised to power 2 equals to 4. So they are nothing but power of 2 are only one bit is set in each power of 2. Let's say if you take 8, it is 2 power 3. This will be unset and this only this will be set. So this is you what you have to keep in mind while solving the problem. This is a hint. So the numbers or elements of the numbers array being power of 2 is a major hint in this problem. In one operation, you must apply the following changes to the array. These two operations should be applied together. Then it will be considered one operation. Choose any element in the array such that the element's value is at least greater than 1. Remove the element from the array and half the element and add it 2 times. What the problem statement is saying is, so let's say for example the numbers were 2, 4, 8 and 16. Now let's say I decided to pick 8. Now what we will do, we will remove it from the nums array, divide it by 2, and what will be the result? It will be 4. Add 2 occurrences of 4 to the array. So the new array will be 4, 4, 4 and 16. So this will be one operation. Okay, till now we are clear, I hope. Return the minimum number of operations you need to perform so that nums contain a subsequence whose elements start sum to the target. So you have to minimize these operations, and so that there is a constraint provided that there should be a subsequence whose element sum is equal to the target. Equal to target given, and we have to minimize the operations which will generate a subsequence in the given array, so that there should exist a subsequence in the nums array whose sum is equal to the target. A subsequence is nothing but a sequence generated from the original array by maintaining the order by deleting some or zero elements from the given array. For example, a subsequent valid subsequence can be two for this array 2, 4, and 16. Another valid subsequence can be 2 and 16. So you can see the relative order of the elements are not changing. If you consider this as a subsequence, it will be wrong, since the relative order of these two elements are changing. 2 is coming before 16 in the original array, and in the subsequence that you are generating, 16 is coming before. So it is not a valid subsequence. These two are valid subsequences. So I hope what a subsequence is clear to you. So also it is being mentioned in the problem statement also, a subsequence of an array is that can be derived from an array by deleting some or no elements without changing the order of the remaining elements. I hope it's clear to you now. So this is what you will be doing now. What the hint we have taken, uh, each of the power of 2 will be a single set bit. Each element will be a single set bit. Each element will have a single set bit in binary representation. And if you were to form a target sum by taking elements of this particular nums array, let me quickly change the slide. Then all the values in the target can, let's say the target value is x. Now this x can be also represented by a 32-bit integer, since in the bounds it's given that length of the array is of order 1000 and nums value is from 2 raised till 2 raised to power 30. So it can be very well fitted into a 32-bit integer variable. So let's say the target value is x. So we can represent it in the form of bits, and all the elements in the array are nothing but single bit representations. Single bits is set in all the elements. So you will count the frequency of bit positions. Let's say two elements are given to you. For example, 2, 8 are given to you. 2 and let's say 2 and 4 is given to you. And I decide to pick out 4 and apply that operation of dividing it by 2 and getting two 2's and adding. So let's consider the binary representation 0, 1, 2, 3, 4. Now first bit will be set in all these numbers. So how many times first bit will be set? It will be set 3 times. and we will check how many times first bit is set in the target variable. Let me quickly change the color. Let's say it was set one time or two times. Then we can easily determine whether there exists a subsequence which can sum up to target with the help of bit manipulation. So what we will be doing is we will be counting the frequencies of set bits positions of all the numbers, and then we will be checking set bits in the target. Let's say only let's say some let's take an example. This is a 32-bit integer 0 1 2 3 4 5 6. Let's say this bit, fourth bit, and the second bit is set, and second bit and fourth bit are set since. So, and you are given some number. Let's say you are given 2 and you are given 16, for example. So, as you can see, the second position is set. Uh, let's say this is set. So, accordingly, you will be taking the frequencies, and after you have done uh, checking for the bit position, let's say the for position 1 there were 3 frequency available and you only needed 1, so remaining 2 can be used up to from another bits. Let's say 2 plus 2 will be 4. Now it was each 2 was 2 raised to power 1 and 4 is 2 raised to power 2. So you can see the relation. So let's say frequency of nth bit can be uh, driven, or let's say we can add the n minus 1th bit frequency divided by 2, which will add to the n plus 1th bit. For example, here 2 raised to power 2 and 2 raised to power 1s were there. So for first bit there was 2 frequency, and already there was 1 frequency of 2 raised to power 2. So 2 divided by 2 plus 1. So this 2 position frequency 2 power frequency will be 1 plus 1, which will be 2. So 4 will be occurring twice, since it was something like this. Now if you add these two, 4 will be occurring twice. Now 4 is 2 raised to power 2. So the second bit is set. Second bit is set 2 times now. So this is another observation. So we will greedily, what we will do is we will apply a greedy solution. Greedily pick only required set bit frequency, and carry the contribution frequency of other positions. It will be more clear to you in the coding part. So also you may ask how we will be deciding how many operations we are requiring. Let's say uh, there is a bit missing. This bit is not set initially, and you are currently checking for this bit. Let's call it absent bit. Initially in the array there is no such element for which this bit is set, and let's say for this element uh, a bit was set. We are traversing in this direction from the 0th position to 31st position. We are going. So let's say this, and there was another bit that was not set. These red ones were not set. So how many operations you will be requiring to cover these bits? You should divide your number by 2 only. So it will be nothing but, let's call this, for example, left. It will be, let's call this absent bit position. Nothing but absent bit position, or let's call this position only, minus position. So those number of operations will be required to make these set these bits, to uh, extract the contribution by dividing the number from 2 in the given array. So this will be the contribution, and in case there is no such element, then that can represent, that can uh, cover up these bits, then you will return -1, indicating that the target sum cannot be found. I hope it's clear to you. So let's move towards the coding part. So what we have done is, we are counting the frequencies of each bit position, counting the number of times each bit position is set in a 32-bit element of nums array. So once we are done with counting the frequencies, we will greedily pick only one frequency, one set bit occurrence from the bit frequency array, and rest other bits, rest other occurrences of a particular bit position will be carried forward to the further bit position +1. So it is that case only in which 2 raised to power 1 was carried to 2 raised to power 2, and uh, after we have done with checking for the bit frequencies, if the current bit position is set in the target bit, then you will do the following. uh, if the current bit is set in the target bit, in the target number, then use one bit position occurrence, and if there is no occurrence of set bit on that particular bit position, then mark it as a absent bit. Then mark it as absent bit and take the minimum value of current absent bit position and overall absent bit position. Since the operations we will be doing will anyways cover the bit positions, absent bit positions with larger values. Since you will be keep dividing by 2, so those absent bit positions which are larger than the overall bit position will naturally be covered. So you will be taking the minimum of the absent bit position, and if that's not the case, if the bit is not absent, then you will simply decrement the frequency of that bit position, and this is just a random number that I have given. Anything greater than 31 will work absent bit position initially, and if the current bit position is set, it means there is at least one occurrence of current bit position. Then from current bit position to absent bit position, you will be doing the number of operations, and the number of operations will be these, as I mentioned in this part also. This part, let me quickly change the color. So these will be the number of operations that you will be requiring, the distance between the position and minimum absent bit position, and then you will set the absent bit position to the value indicating that there are all the absent bits are covered. It indicates that all the absent bits till now, bit positions till now are covered. So, and then since the adding of 2 powers of 2 is of zero cost, is not costing us any operations, so we will be reusing those frequencies, left out frequencies of the current bit position, and we will be reusing them to the 1 bit position ahead, as I discussed in 4, 2, 2 example. And at last, if there are still some absent bit positions required to be covered, then in that case you will return -1, else you will return operations done, number of operations done. So this wraps up the third problem of the contest. Now let's quickly move towards the fourth problem of the contest. So the problem's name is maximize the value of function in a ball passing game. So you are given a zero indexed array receiver of length n and an integer k. So there are initially n players, each with a unique ID from range 0 to n minus 1, and each of those players are passing the ball between among them, and the receiver array indicates that it's mentioned here, players can pass to themselves or the ID of the player who receives the passes from the player with ID I. So let's say this is the player with ID 0. Let me quickly take an example. Let's take this example. Let's mark the IDs of the players or the indices of this receiver array 0, 1, 2. Now the player with ID 0 passes the ball to player with ID 2. So 0 will pass to 2 and the player with ID 1 will pass the ball to 0 and player with ID 2 will pass the ball to 1. So this will be the way the ball will be passing the ball. So this is what the receiver array indicates. So now let's move further in the problem statement. You must choose one of the players as the starting player of the game, and the ball will be passed exactly k times from the chosen starting player. Let's say I decide to pick 0 as the starting player. For the chosen starting player x, we define a function f of x. X is here 0 now, and the IDs of all the players who receive the ball during k passes. So if 0 starts, 2 will be receiving, 1 will be receiving, and again 0 will be receiving if k happens to be 3. So who receive the ball during k passes, including the repetitions. So repetitions can occur. If let's say k is 3, then initially 0 will be having the ball, then 2, then 1, then again 0 will be having the ball. Let's say if k was 4, then again the ball will come to 0. 1 pass, 2 pass, 3 pass, and 4 pass. So the passes will continue like this. So function is given to you, which is ID of the first receiver, ID of the second receiver, which is nothing but receiver value at for x index, and so on. It will continue. So basically, let's have a look at the constraints in this kind of problem. Uh, and here is of order 10 raised to power 5. The number of players is of order 10 raised to power 5. And k's value is very large. It's 10 raised to of order 10 raised to power number of passes, 10 raised to power 10. So let's say if I apply a brute force approach and one by one picking each player as starting point, starting player, then total number of operations will be required will be order of n into k, which will be 10 raised to power 5 into 10 raised to power 10. It is 10 raised to power 15. Now these 10 raised to power 15 operations are greater than 10 raised to power 8 operations allowed. So basically, if the number of operations of your program becomes greater than 10 raised to power 8 operations or equal to 8, then you may get a TLE. and your solution will not be accepted. So in order to get your solution accepted, you should optimize this brute force. Now, how you will be doing the optimization part? We will be using the concept of binary lifting, or say binary jumping. I will be providing a link of a video describing this binary jumping. It is a prerequisite of if you want to move further in the solution. If you do not know binary jumping, then or binary lifting, then you should watch that video from the given link and then only proceed further. Now, I assume that you have watched that video. Uh, what we can do is, since k is of 10 raised to power 10, so what will be the logarithm log base 2 of 10 raised to power 10? It will be something near 33. So with the help of, let's say, 33, or for safe point, let's say add 3 or 5 value to it. So from 35 to, let's say, 38 bits, anything between this range, or 33 to 30, 34 to 38, you can make a representation for k. How be the maximum value of k, binary representation for k. Now, if you check only the binary representation of the k, then, and if you, let's say, take the contributions, what was happening is, let's say this was receiver one or the start player. He was passing to someone, he will pass to someone, he will pass to someone. It will continue till k times. Number of passes will be k times. So if, let's say, each of these passes can be represented in powers of 2, and each node will be having two values, what will be those values? So one thing I forgot to mention is the f of x that is given to you, you have to maximize its value. So you have to take the maximum value of, we have to take such a starting point such that the f of x value will be maximized. Now, what will be the two things that will be stored at each node? Uh, there will be the current ID of the node and the value that node will add to the overall value sum, value added by this node. Value added by each node will be the value added by its parent plus value added by value plus ID of node. Node is nothing but the current receiver. So basically, what we who will be the parent? the player who passed the value to the ball to current player. Let's say k's values were something like this. This is the binary representation of k. Let's say 0, 1, 2, 3, 4. Now let's say these two bits are set. This bit and this first bit. This is set. Now what you will do is to pass the ball k times. You will go up by these number of steps plus these number of steps, which is nothing but 2 raised to power 3 plus 2 raised to power 1. So let's suppose k's value was 9. Then you have to go these number of steps upward. So first you will go 8 steps upward. Let's call these are the 8 steps you go. 8 steps upwards means, or forward means, you pass the ball 8 number of times. Then after these number of times you will again pass the ball 1 number of times. So as you can check, if k's value is very large, then log of k passes are required only. Log base 2 k passes are required, since we are checking only for the binary representations of k, and we will form the contributions. We will form a contribution array denoting binary contributions of each player position. So this thing will be more clear to in the coding part. I assume that you have seen the video that I recommended to as a prerequisite for this solution. Now this is nothing but a small tweak of standard binary lifting algorithm. What you are doing is we are taking a receive ID value 2D array. It is nothing but a dynamic programming on trees. Those of you who are new to dynamic programming and trees also, I will be providing a link for these two. Uh, for these two will be provided to you in the form of article, and you can check those article out, and then you can proceed further. So what you are doing is from the current ID, you are moving 2 raised to power positions ahead, or say upward, or passing the ball this number of positions from the current ID. So this is what the receiver ID value denotes. So this is the previous receiver, or the parent of the current player, current receiver. So the value that the current receiver will be contributing will depend upon the what value is being contributed by value sum by its parents that is coming to it. So this will be the previous receiver. What will be the value they will be adding? This will be representing the value they will be adding uh, for each entry in this 2D array. It will be current ID and the value the current player will be adding. or say the current value of the value sum, current value, previous value of value sum plus the current uh, value that the player will be adding. So we will form the state for the current player, form the state for the current player based upon the state of the previous player, or say its parent. And then we will use this state table for 2D array. State here is current receiver ID, comma, current value sum for a current player. So as you can see, case value is of maximum case value is 10 raised to power 10. So I have taken a logarithmic log 2 log with base 2 and added a value, so that when I declare a 2D state table with this size, the value should not overflow. So as you can see, the case value is reduced from k to only this value. It will be something 38, around 38. So this is what you will be doing. And if you will be checking for each player, you will consider him as the starting player and perform k passes in terms of binary representation of k. So instead of second loop going as large as many times as 10 raised to 10 raised to power 10, it will go till log base 2 10 raised to power 10, and this loop will be running for each player. Each player being considered as the starting player of the game, and we will calculate f of id for each player, and at last return the maximum value of f of id. So this is we iterating over the binary representation of the k of k. So if the current bit position is set in K, then we will make we will do calculations. As you can see here, for example, two positions were set in this value of K. K was 9, as we can see. So the position 3 and this position was set. So you will be checking contributions only for this position and this position and adding their contributions. I hope it's clear to you. And for adding those contributions, this array will be used. Which array will be used? This receiver ID value array. This array will be used. This is a dynamic programming approach. And at last, what you are basically doing is this will be your current stock. This was your previous stock. These are nothing but these values of K only. So each node is storing two values. That's why we were storing these two values, current ID and value added. So for parent of each node, we will be checking the previous receiver, and we will continue moving further and adding the value to the current value sum, and at last we will return the max value sum. So if you are still having any doubts, please feel free to ask them in the comment section, and that's pretty much it. This wraps up the fourth problem of the contest, and thank you for watching. Thanks.